Are we truly on the doorstep of a humanoid robot revolution? This question sparks intense debates as the rapid progress of AI chatbots contrasts starkly with the slow advancement of robots mastering real-world skills. But here's where it gets controversial. While many tech luminaries like Elon Musk boldly predict humanoid robots performing intricate surgeries or managing household chores within a few years, prominent experts warn we may be biting off more hype than reality. In two recent papers, UC Berkeley roboticist Ken Goldberg sheds light on why robots aren't catching up to AI chatbots in practical abilities, despite how quickly chatbots have gained fluency in language. AI chatbots, powered by large language models, LLMs, are trained using vast amounts of text data scraped from the internet, effectively absorbing the written knowledge of humanity. This surge of proficiency has led to chatbots becoming personal assistants, customer service agents, and even virtual therapists. Inspired by this, some tech leaders speculate that similar methods will soon produce humanoid robots capable of replacing factory workers, serving as in-home helpers, or even outperforming top surgeons. Goldberg, however, challenges this optimism. Speaking in a recent interview with UC Berkeley News and through his published work in Science Robotics, he introduces what he calls the 100,000-year data gap. Simply put, while AI chatbots have access to enough textual data that a human would need around 100,000 years to read it all, robots lack comparable data sets of real-world manipulation tasks. Robots can't feasibly be trained at such scale yet, especially for the complex, dexterous actions humans perform daily. Take a common task like picking up a delicate wine glass or changing a light bulb. These require an extraordinary level of precise perception and finger control that robots currently struggle with. This phenomenon, known as Moravec's paradox, highlights how tasks humans find effortless are some of the hardest for robots to learn. While AI has beaten humans in strategic games like chess and Go, a feat many find impressive, those games don't require the physical coordination and spatial awareness that grasping a glass does. Goldberg's analysis goes further to explain why. Video data of humans performing tasks, such as from YouTube, aren't sufficient for robot training. Translating two-dimensional images into detailed three-dimensional motor actions is exceptionally challenging. Though simulated environments allow robots to practice actions like acrobatics or running and then transfer that knowledge to the real world, this approach falls short for fine hand manipulations needed for trades like plumbing or electrical work. Currently, some systems rely on teleoperation, where a human remotely controls a robot's movements to perform tasks. While this generates some training data, it is slow and tedious. 8 hours of human work yield only 8 hours of robotic data. Considering the vast data needed, this method simply can't scale to bridge the data divide anytime soon. This leads to a big debate among roboticists. Many still adhere to traditional, good old-fashioned engineering, leveraging physics, mathematics, and environmental modeling to build robots. Meanwhile, a growing camp believes that sheer data-driven machine learning will eventually solve robot dexterity without relying on conventional engineering principles. This philosophical rift echoes a broader scientific paradigm shift similar to revolutions seen in physics history. The data camp is bolstered by significant funding and enthusiasm from younger researchers, investors, and influential figures, while established experts urge caution. Goldberg advocates a balanced path forward. Continue using engineering and scientific principles to develop functional robots that can then collect valuable data autonomously, effectively bootstrapping training efforts. Successful examples include Google's Waymo self-driving cars, which improve by gathering data from everyday operation, and Ambi Robotics, whose parcel sorting machines enhance performance through real-world usage. Regarding jobs, Goldberg stresses that blue-collar roles involving manual trades are far from being replaced by robots anytime soon due to these dexterity challenges. However, white-collar positions involving repetitive administrative tasks, such as hospital intake forms or basic customer service, are more vulnerable to AI automation. Still, nuanced human interactions, like empathizing with frustrated customers or delivering sensitive medical diagnoses, remain a tough nut to crack for machines. This ongoing anxiety about robots stealing jobs is nothing new. It has surfaced repeatedly over human history. Yet, Goldberg remains optimistic that humans have many productive years ahead alongside robotics and AI, with thoughtful integration rather than wholesale replacement. But here's the twist. Will embracing advanced, data-driven methods sideline traditional engineering wisdom prematurely? Could this lead to a costly bubble of inflated expectations and subsequent disappointment? What's your take? Are we rushing into a humanoid robot revolution that's still decades away? Or is groundbreaking change just around the corner? Join the conversation and share your thoughts. Do you believe the hype or the caution? The future of robotics is unfolding, and your perspective matters.